some of the assignments that you have require you to turn an asset beta into an equity beta to use as part of your calculation of the WACC. You needed to do that in one of the guided reading assignments in the first corporate finance course. You also need to calculate an equity beta from an asset beta to value the wineries in M&A and wine country. Other assignments require you to unlever equity betas of several comparable companies to calculate asset betas and then to relever them. For the final project, you will need to unlever equity betas for comparable companies and then to average the unlevered betas to calculate an industry beta. Then you will need to relever that industry beta with a different capital structure to calculate the equity beta for a company whose beta is not published. Consequently, I am making a brief video here describing the process for how we unlever and relever beta. If you look up the beta of a company, the beta that you see is its equity beta. That is the beta that you use in CAPM to calculate the cost of equity. If, as in the winery case, you are given an asset beta, you need to lever it. When the company has more debt, that will increase the cost of equity, the required return on equity, because now the return to the equity holders is riskier since the company must pay the interest payments on the debt before returning cash flows to the shareholders. We are going to use a formula known as Hamada equation, which you can see on this slide, to lever our asset beta. The Hamada equation is an attempt to quantify the higher risk due to financial leverage, meaning the use of debt. The symbols used in that equation are on this slide. Then you will use that levered beta to calculate the cost of equity using the CAPM, capital asset pricing model. Then you will use that cost of equity along with the after-tax cost of debt to calculate the WACC. To show you how to unlever and relever beta, we will look at a sample problem of a fictional company. You can pause the video to read the problem. We will work the problem in Excel. So let me open the Excel. We have a fictional company where we need to unlever its equity beta and then relever it because we are assuming there will be a change in the capital structure. The Hamada equation is in row 7 of this spreadsheet of the Excel. The unlevered beta of a firm represents the business risk as if the firm had no debt. The unlevered beta is also known as the asset beta. The Hamada equation shows that the levered beta is equal to the unlevered beta, beta sub u, multiplied by 1 plus the debt equity ratio multiplied by 1 minus the corporate tax rate. If there weren't any taxes, we would know that having debt is making the firm even more risky. But by having taxes, something you will learn when we look at capital structure, means the debt is a little bit beneficial because you can deduct your interest expense. and from your other costs and your business revenues to get a lower taxable income. Interest expense is tax deductible, and that is why we multiply the debt equity ratio here by 1 minus the tax rate. Having a positive tax rate reduces the impact of leverage on our risk. We need to calculate a project beta that reflects the risk of the project or a company beta that reflects the risk of the company, and we need to pay attention to this use of debt in our capital structure. Our fictional company originally had a debt equity ratio of 2 divided by 7, but it will issue more debt, perhaps to buy back shares or for some other reason, so that its new debt equity ratio will be 0.9. When we unlever the beta in rows 8 and 9, we must calculate what is in the square bracket in our Hamada equation. The corporate tax rate is shown in cell N4 as 30%, N5 as 30%. The 1 minus the tax rate is 0.7. That's in N6. Multiplying 0.7 times the debt equity ratio gives us 0.2. Add 0.2 plus 1 to get the term in the square brackets, which equals 1.2. Then divide by the original levered beta of 1.5. So divide 1.2 by 1.5, and you have the unlevered beta of 1.25. As you can see in cell B9. This is our answer to part A of the problem. Next, we want to relever beta with a new debt equity ratio equal to 0.9 using the Hamada equation. 0.7, which is 1 minus the tax rate, is multiplied by 0.9, the new debt equity ratio, which equals 0.63. Add 1 to 0.63, then multiply 1.63 by the unlevered beta of 1.25. That equals 2.0375. That is our new levered beta and the answer to part B of the problem. Next, we use our new levered beta in the CAPM equation in cell B12. The risk-free rate is 4% as shown in cell N2. The market risk premium equals the expected return of 8.5% minus the risk-free rate. The market risk premium is 4.5% and is calculated in cell N4. The return on equity with the new beta is the market risk premium of 4.5 multiplied by the new levered beta of 2.0375. Add to the risk-free rate of 4%. It is calculated in cell B12 as 13.16875%. That is the answer to part C of this problem. To calculate the WACC, weighted average cost of capital, we need the new cost of debt, which is given in cell N1 as 5%. We also need the corporate tax rate, which is given in cell N5 as 30%. And we need the percentage of debt and the percent of equity. In our financing, we are assuming that this company does not use preferred stock, only debt and equity. To calculate the percent of debt, also known as the weight of debt, we need to convert the new debt equity ratio into the percent of debt, which is also known as the weight of debt. We need this process is shown in rows 16 and 17 of the Excel. The calculation is as follows. If the debt equity ratio is 0.9, that implies the D equals 0.9E. Then we can solve for percent D, which is the weight of debt, W sub D, which equals D divided by D plus E, that is, debt divided by the sum of debt plus equity. As shown in cells I16 and through Q17, the percent debt is 0.9E divided by 1E plus 0.9E, which equals 0.9 divided by 1.9, which equals 0.47638 and is calculated in cell N11. The weight of equity equals 1 minus the weight of debt, so 1 minus 1.473684 equals 0.526316 and is calculated in cell N13. Now we use those numbers in the WACC equation, which is shown in row 15, in cells A15 through D15, as WACC equals percent expected rate of equity plus the percent of equity times the required return on equity plus percent of debt times the required return on debt, the interest rate on debt, times 1 minus the tax rate. The WACC equals the percent of equity multiplied by the cost of equity plus the percent of debt multiplied by the cost of debt multiplied by 1 minus the corporate tax rate. The answer is 5.888% as calculated in cell B16 as a decimal and converted to a percentage in cell D16. So now you can unlever equity betas, lever asset betas, calculate the required return on equity, and calculate the WACC, which you then can use to value a company or a project using the DCF, discounted cash flows method. Thank you.